So this video is about how to determine the images formed in concave mirrors and in convex mirrors. So in concave mirrors, we know that it has a center of curvature and focus at the reflecting side, right? And for convex mirror, the focus and the center of curvature is actually on the other side of the mirror. So how do we draw images formed by the two mirrors? So let's start with a concave mirror first. So there are rules, and those rules are written actually in your book, but I thought I would try to explain them. So for example, you have an object here, right? You have an object somewhere, maybe somewhere here, right? And just pick a simple object like an arrow, right? And so this arrow will be sending light rays towards your mirror, and it will form an image. So how do we determine how or what the image would look like? The answer is we use a technique called ray diagramming. So we diagram the light rays that are incoming to the mirror and the light rays that are reflected. So it's actually found on your page, on your learner's material, page 185. So there are 4 rules. You have this first rule, the second rule for concave mirrors, you have third rule here, and you have the 4th rule. Okay, so let me elaborate what those rules are. So if this is your object and you have your mirror, the first rule says that you have to draw a PF ray. It's a ray that is parallel to the principal axis and is reflected by passing through the focus. So by the way, the principal axis is this line here that divides the lens into 2. This is the principal axis. So it says that if you have a light ray coming from the object, hitting the mirror in the original orientation, which is parallel to this principal axis, then it's going to be like this. So this one hits the mirror, okay, and then when it gets reflected back, it will pass through the focus. So for now, let me erase this because it will get in the way. Just remember, this circle one is the center of curvature and this one is the focus. So as this light ray, which is parallel to the principal axis, hits the mirror, it will be reflected such that it will pass through the focus. So remember, this is the focus, so it will be reflected like this. Okay, that's the first rule. We have the PF rule, parallel and then passing through the focus rule. Okay, now the second rule is the opposite, which is the FP rule. So that means you are going to have a light ray that is passing through the focus first, and then when it gets reflected, it becomes parallel to the principal axis. So totally opposite. So I will start from the head of the object still, but now it passes through the focus here. It hits the mirror, right? And then once it hits the mirror, it gets reflected, but this time it will be parallel to the principal axis. You see, these first 2 rules are just the opposite of each other. So the first rule is parallel focus, Second one is it passes through the focus, then becomes parallel. Okay? Then the third rule, if you flip your book to page 186, is the CC ray. So this is a light ray that's passing through the center of curvature, and it will be reflected in the same path. So what that means is this: if you have a light ray coming from the top of this object and then it passes through the center of curvature, remember this is center of curvature, like so. As it hits the mirror, it gets reflected in the same line. So it's actually, you are going to make a line which is on top of this incident ray going out. So please interpret this as a light ray coming to the mirror and then gets reflected back on the same path. Okay, so that's the third ray. Now the fourth ray says that if you have a V-ray is a light ray directed towards the vertex, reflects at an equal angle from the principal axis. By the way, the vertex is where the principal axis meets the surface of the mirror. So that vertex is here. Right? So that vertex is somewhere, is here at this point. So I'm going to draw a light ray from the top still, and then hits the vertex like so. Right? Then again, it will be reflected at the same angle. So I will estimate this angle here from the principal axis, and I will make the same line. Okay, so now you have completed the 4 rays. So let me point out where those rays are. So the first one is called the PF ray. So you have a ray that is parallel to the principal axis and then passing through the focus, the PF ray. Then the FP ray, it's a light ray that passes through the focus first, here. Then when it reaches the mirror, it gets reflected in a parallel line with respect to this principal axis. That's the second one. The third one is a light ray that passes through the center of curvature, which is this one. It hits the mirror and then gets reflected back on the same line. And then lastly, the fourth one is you have a light ray that hits the center or the vertex of the mirror, and the angle that it forms with the principal axis, this one, is the same angle that it forms when it gets reflected. Okay? Now, how do we determine in the mess of arrows there where the image is? Well, this is how you determine it. Remember, all of those 4 light rays came from the top of the arrow, right? And all of those 4 light rays, when they get reflected, they meet at one point, right? They meet here. So this is 1, 2, 3, 4. So meaning, if these are the light rays coming from the top of the arrow, that means there is an image formed right there. So this is your object, and the image form is this. Okay? So in this case, your image for this particular case is smaller, right? So you can notice the object is quite bigger than the image. It is inverted because, see, the arrowhead is pointing up, but the image is pointing down. It's inverted, and then it is real. Real, that means you can really see light rays meeting at that point, and its location is somewhere between F. Remember, this is F and this is C, so it's located between C and F. So the location of the image is between C and F. It is smaller, it is inverted, and it is real. So that is an example. That's just one example of an image that can be formed in a concave mirror.